Hi, welcome to this time series virtual summit session on the power of Influx at the edge. Demo and exploration of Telegraf and InfluxDB on Microsoft Azure and IoT Edge. That is a lot of words, so let's find out what they mean. First, a quick introduction. I am Chris. I will always be Christopher to my grandma, so there it is. I'm a senior developer with Nortal. Nortal is a global company with offices all over the world. I am with Nortal in the US, which is up in Kirkland, Washington. Let's start with the edge. Edge computing is very important for the Internet of Things. When we talk about the edge, we're talking about moving workloads from the cloud to a location closer to the end user. This could be a local node, or it could be a node on their network. There are several reasons to do this. Among the benefits of edge computing are that by moving the workload or the service closer to the end user, we are reducing latency, so we can have near real-time responsiveness from our services. If we have devices that may be subject to connectivity that drops in and out, so maybe they don't have constant internet access, by having a service local to the device or somewhere accessible to the device, we're able to provide that service without interruption to the end user. Additionally, we reduce bandwidth consumption due to the ability to process data locally and not make that call out to the cloud. Additionally, we're able to reduce noise on the cloud end by only sending out the data that we need to. In addition to the benefits, there are some challenges. Some of the challenges around edge computing are device setup. We want to make sure that the devices are easy to set up and configure and don't require a lot of skill or time for the end user. We want to make sure that devices are secure so that the workloads and services running on a device are the workloads and services that we have specified. We want to make sure that updates are available to the device, and ideally that these updates are automated or pushed from the cloud. We have to contend with the challenge of having restrictive device resources. So there may be limited processing power or storage on the device. Azure IoT Hub and IoT Edge. Over at Microsoft, they have helped us along with some of these problems. They provide a device provisioning service and security through their hardware security module and certificates. This helps us with device security and ensuring that the workloads are verified workloads. This helps us on the cloud end by ensuring that only the devices we have provisioned are devices that are authenticating. We're able to run our workloads on devices on IoT Edge using modules, which are essentially containers. Microsoft also provides a mechanism for message routing and for device twins, which allow us to modify the configuration of devices. And finally, Microsoft also provide integration with their other services, which is nice to have too. The Solution Accelerator. So what I have for you is a demo. The demo is a Solution Accelerator, which is basically a quick start template for you guys. So it's going to deploy some infrastructure and demonstrate some capabilities. It is fast, simple deployment with minimal configuration, and it displays a number of use cases so that you can get an idea of what you can do with Influx data products, the Microsoft Azure IoT Edge. This is what we're going to deploy. So we're deploying to a resource group 2 VNets. Those virtual networks are representing a cloud virtual network and an edge virtual network. On the edge side, we are deploying a couple of VMs. One of those VMs is running Microsoft's IoT Edge. That is to simulate a device. So this would be a device connected to our edge network. Additionally, we're deploying a second server, which is running InfluxDB. This is going to be our edge instance of Influx. On the edge network, we have 2 container instances running, both of which are simulating OPC devices. If you're not familiar with OPC, OPC is just a protocol that's used a lot in manufacturing. So these are representing factory devices which will be communicating basic information about the running of certain machines. In our case, the edge is generating random data. Our simulated device is going to authenticate with the Azure IoT Hub, register itself with the Azure IoT Hub, and the messages from the OPC simulators are going to be pushed both to the InfluxDB Edge instance and to the Azure IoT Hub. Once those messages are received by the IoT Hub, that is going to trigger on the cloud side an Azure function, and that Azure function is going to make a simple HTTP request to write the message to a cloud instance of InfluxDB. Here we've zoomed in on the simulated edge device. So within the device, we are running the IoT Edge runtime. You can see there that the Edge Hub, which is a component of the IoT Edge runtime, is connecting out to the Azure IoT Hub in the cloud. You also see a Telegraf container there. That is a module that's initiated by the Edge agent, also a part of the IoT Edge runtime. The Telegraf instance is defined in a configuration in the cloud, and the IoT Edge runtime knows to bring that up. It's verifying the connection before any messages are sent to the Edge Hub. You can see that we also have Telegraf connecting out to our 2 OPC simulators. As part of the work we've done with Influx, we have developed plugins, both input and output, for connecting to the IoT Edge runtime, as well as the ability to input and output metrics from OPC sources. The Telegraf is collecting metrics from the OPC simulators, and it is both writing them to the Edge Hub, which is pushing them to the IoT Hub, and additionally it is sending those out to our Edge instance of InfluxDB. Why might we want to do that? Why would we want to send it to an Edge instance of InfluxDB? So in this particular example, we may wish to do that if we have data residency requirements, or if we wish to have specific metrics available to a site, rather than in cloud. Also, another use case, rather than using Telegraf to input metrics into the Edge Hub, using Azure IoT Hub's routing, which is very powerful, we could have messages that are received by the Edge Hub there on the simulated device, piped into Telegraf, and it could be writing metrics from other sources that is picked up by the Edge Hub into an InfluxDB Edge instance. Okay, so let's do a quick deployment. Here we have our solution Accelerator. We have details on what's being deployed and how to deploy it, some details of the variables that you will need to provide, but I think it's fairly straightforward, and I will show it to you right now. I'm going to go into the deploy folder. I'm going to scroll down to our README. I've got a one-click deployment, almost one-click, right here. I'm taking to the Microsoft Azure portal. I'm going to create myself a new resource group. I'm going to set a name for my environment and my test environment. I'm going to set a location for my cloud resource group. I'm going to leave that as West Europe. And my edge location is going to be West US. I'm going to give my VM an admin username and an admin password. I've got the base size of the VM that I wish to use. We can change this as long as it's available in the 2 regions that have been selected. These regions could be the same regions. No reason they need to be different, but for the purposes of this demo, they're going to be. InfluxDB option. So here we have the option of either open source or enterprise. There's some additional configuration to do with enterprise, That is detailed fully in the instructions. Here, I'm going to do open source for speed. Agree to the terms and conditions and purchase. Our deployment is underway, and as you can see, it starts to deploy the various components. All the different dependencies are managed for you. So all you should do is watch as this quickly turns green. I'm going to pause it there, and we'll save a few minutes. Okay, so here we are, deployment completed. Let's see how long that took. Here, a sea of green, that's nice. Looks like we took about 11 minutes, if that. We've got some nice outputs. So we've got IP addresses, public IP addresses for our cloud VM with Influx DB, our edge VM with Influx, and also our IoT edge server. So if we want to explore that a little bit, we can do that too. I am going to take our cloud IP address and copy that. First, let's go to the resource group and see what we've deployed. So, let's see here, we've got our app service, which is, here's our app service, which is the function app, which is taking all the messages received by Azure IoT Hub and then writing those to our cloud instance of Influx DB. We have 3 virtual machines. We have a cloud VM with hosting our Influx DB, and we have 2 edge VMs hosting our Influx DB and our IoT edge device simulator. Up here as well, we've got our 2 container instances, also on the edge network, simulating OPC devices. Let's click on the IoT hub, and we should, if we see here, our IoT edge device. Yep. So we can see we've got connected clients and various modules on there too. So you can see we've got Telegraf running on there, as well as components of the IoT Edge runtime, the Edge Hub, and the Edge agent. If we go to the connections, I can see Telegraf is connected. I click on Set Modules up here for the device. We can see the Telegraf module was configured. We've told that container to run with a specific configuration. Just a quick reiteration of what we have deployed. Our edge network, our cloud network, our OPC simulators are generating randomized data. Telegraf is reaching out to those and picking up changes and piping them into the IoT Edge runtime. The IoT Edge device is connected to the IoT Hub, and those messages are being written to the IoT Hub, and then a function app is picking up those messages and writing them out via HTTP request to the Influx DB API on our cloud instance. We also have the same messages from the OPC simulators being written to the Influx DB Edge instance directly via Telegraf. Why Influx? So, what's the point in getting all these things to work together? Microsoft has time series insights. You can write messages from the IoT Edge to IoT Hub to a number of places. You can put them into blob storage and have time series insights do its thing on the blob storage. We can have the IoT hub trigger the messages going to a service bus. With InfluxDB, you're getting a highly performant time series database that was built for that purpose. Optimized storage with InfluxDB, and the ability to run very powerful queries. Additionally, the Influx data products come with an open source community. So, as I will show you with Telegraf, there's a wide variety of plugins connecting out to different services and protocols that is constantly being added to by an enthusiastic community of developers. The Influx data ecosystem isn't just a database, it isn't just Telegraf, but the entire tech stack is put together to create an entire time series suite. Metrics gathering, the database storage and querying, the ability to run insights, and with chronograph and dashboards and data visualization. InfluxDB has an enterprise option, as we've already seen, as well as a cloud option. These options are highly scalable horizontally, and they are cloud agnostic. So we can test with the open source version of InfluxDB, and if we decide we like the product and we want to create something more robust, we can deploy the enterprise version of the cloud stack into Azure or AWS or anywhere else we see fit. And additionally, it's a stack that we are presumably all familiar with. So there's not a lot of relearning some cloud-specific products. We can deploy this, we can deploy Influx anywhere. Okay, so use cases. I've already explained some of these in superficial detail. So one reason we might want to be able to control the routing of our metrics locally on an edge network would be to maintain data residency. If there's certain data that can't be transmitted up to the cloud, we might want to keep that on-premise, or keep it on-premise for other security reasons. Using the Influx products, as I mentioned, avoids cloud lock-in. The product that will run pretty much anywhere. So if you decide to move later, you are able to do that. The plugin we've developed for Telegraf, specifically that communicates with the Azure IoT Edge runtime, allows for very powerful message routing. So as I mentioned, it's both input and output plugins, which means we can receive metrics from all of the different services and protocols that the Telegraf plugins support, and write them to the Azure IoT Hub. Additionally, we can also receive messages through the IoT Hub specified in the, if there's a particular module that's also deployed to a device, and we want to make sure that specific messages from that are forwarded onto Telegraf as well as the IoT Hub, we're able to do that. And finally, compatibility. Because of the sheer number of plugins available, both input and output for Telegraf, we're able to connect to a number of services, some of which may not be fully supported yet by other options. That is the end of my deck. Let's go and take a look at what we deployed. So earlier I copied the IP address for the cloud instance, and we are going to go to port 8888, and that is going to take us to chronograph. Chronograph is going to require some minimal setup. We can just go add and next and continue and view all connections. So I've done literally 0 configuration here. I'm going to go to explore, and thankfully we can see OPC data is here, and I can see 2 of my PLCs, my OPC simulators. And I am going to select from this one negative trend data. And we can see that that is generated. For the last few minutes here, we've been receiving data for, we can see for the last few minutes here, we've been receiving data. So involved in that, we've been generating that random data set from the OPC simulator containers. Telegraf has collected those metrics, put them into the Azure IoT Hub via the IoT Edge, and then from there, Azure Functions has taken those messages and written them to a cloud instance of InfluxDB, which is where we're reading them from here. Additionally, if we would like to go to port 3000, we are able to get to Grafana on the same host. Again, this is not yet configured. We can go through a very simple configuration process, and if we like, we can see our metrics in there too. And finally, through the magic of editing, I'm now on my Windows machine, and as you can see, I am accessing this via Power BI and a set of pre-configured dashboards that we have created. If you'd like to download these are also part of our solution Accelerator, available in the Power BI directory. As you can see, we've got two files, the pbit and the pbx. So the pbit is a Power BI template, and you'll be asked to input the IP address of the server you've deployed. And that's sufficient for you to get the dashboards. If you want to see how the sausage is made, access the pbix file, and this will allow you to look at the query in addition to seeing the dashboards and see how that data's been manipulated as we're pulling it into the dashboards. What I hope to demonstrate here by pointing out the various dashboards and visualization interfaces that you can use with this is to highlight the fact that the Influx line is highly modular. So you can substitute out and substitute in your preferred software for various components, whether that's replacing chronograph or capacitor, or indeed even InfluxDB itself. And finally, I'd like to thank you for attending this session. If you'd like to learn more about what we do, feel free to visit us at nortal.com. There you'll find contact information, and we're happy to hear from you.